In this video, we're going to see how to calculate the pH of a weak base. Now, the way we would know that this is a weak base, besides being told based on the title of the video, is that ethylamine is not one of our 8 strong bases. Also, the fact that they gave us a KB is telling us that it doesn't dissociate completely, and so it's got to be a weak base. So, just like we did for weak acids, if I want to know the pH, I need to do an ice table. So, I'm going to take my ethylamine and react it with water. I'll use my equilibrium arrows. All right, if ethylamine is a base, that means it's a proton acceptor. So it's going to take a proton away from the water, leaving me with hydroxide ions. And the conjugate acid of ethylamine All right, so now when I build my ice table, my initial concentration of the ethylamine is 0.40. I don't worry about the liquid water. My hydroxide and the ethyl ammonium ion will start out at 0. Now, because the K is less than 1, I know that it's going to be reactant favored, but I know the reaction has to go to the right because I'm starting out with 0 products. So it's going to go to the right, but just a little bit to the right. So I'll make this minus X. So the hydroxide will be plus X. We have plus X. So at equilibrium, all right. Now to find the pH, what I want to do is plug my equilibrium values into the KB expression. That will allow me to solve for X, which is going to be the hydroxide ion concentration. And once I know the hydroxide ion concentration, we know how to find the pH. So the other thing we're going to take advantage of is, just like with the weak acids, we're almost always going to be able to use the K's small approximation. Right, because this equilibrium constant is much less than 1, this reaction is not going to go very far to the right. So that means relative to the starting concentration, X is going to be fairly small. So I can ignore this minus X due to the K is small approximation. So my equilibrium constant expression is as follows. And if I put in the values from the equilibrium row of my table, I'll have X times X, and I'll just have 0.45. I can ignore the minus X because of the K is small approximation, and we'll finish this up on the next slide. Okay, so this is what we had from the last slide. I've just substituted the numerical value of KB in for KB. So to solve this, I want to multiply both sides by 0.450. And so I get X squared then I want to take the square root of both sides. And so that's what I get for X. Now if we go back to our ice, so this is the ice table that we made before, just a little bit neater because I've typed it out. And we have the X value that we solved for on the previous slide. So X is the hydroxide ion concentration. So I know that is a hydroxide ion concentration. So now all I need to do is find the pH. So I think the easiest thing to do is first get the pH, or first get the POH, and then we can use that to get the pH. So we know that POH is negative log of hydroxide. So my pOH comes out to be 1.80, and we know that pH plus pOH has to be 14. So the pH is going to be 14 minus pOH, or 14 minus 1.80. So my final result, the pH is 12.20.